So this is a notebook with a Colab because I feel most of the library is already pre-installed in Colab, so it's very easy for you to run. Let me just show it in the chat so you can directly run it now. So yeah, so this is just a simple notebook. So to get you started running some PageRank algorithm, and the package we use is mainly from this NetworkX algorithm. And for example, we can first create a directed graph, right? And then we can just use add nodes and add edges. And because it's directional graph, so all of this means the direction. So G to A, or A to G, or B to A. Right. So, and then we can define some layout of the graph nodes, and then we can directly draw the nodes. So this is the graphs we kind of defined. And then we can directly, so the PageRank is already a compiled function from this package. So you can just directly call this PageRank algorithms on G. So if you look at this, it's actually very interesting. You see the parameters, right? So this alpha is kind of that beta, 0.8 or 0.9, right? And then you can also do the personalizations and also max iteration and the tolerance, because it's that power iteration solution, right? So it's a tolerance. And also you can use some weight. I think the weight is on the graph and nodes on the edge. So this is the weight on the edge. Yeah. If none, then all the edges equally important. So let's just use the default settings, and then so the result of this will be a dictionary, right? So this is the node name, and then this is the importance of the node, and then you can directly draw the graphs with the draw again, and this time we can just pass in these importance values as the node size. So you can define your node size over here. And then you see from these graphs, the A is really important, and B and E is very small, so it's not that important because A get most incoming links, right? And since A also point to G and D, so D and G I think get some major importance from A. Well, B and E all point to A, but they don't have other incoming links. So that's why B and E is less important on this graph. And then we can adjust this teleports parameters, right? So usually it's set as by default, it's set as 0.85, I believe. By default, yeah. So the default is a 0.85, right? And then we can actually change it a little bit. Say we run it with a 0.8 or 0.9, and then we can get these values again. So you see, A still has the most, the importance, and with the smaller alpha, so the importance of A kind of increase. So I would say with the smaller alpha, the importance kind of more uniformly spread it over the web, right? So you get a smaller importance for the ones earlier who has a large high scores over there. And for B and E, like they get relatively higher score. Because I believe if you set alpha to 0, then I guess you will have kind of uniform importance for all the nodes. Yeah, and then we can run some personalized PageRank, right? So we can define the set. So right now here I just set the set to be one node, and then this is a score for that. So you can have even a set of nodes, and then you can specify the scores, what probability of this node, and those scores has to sum up to 1. So you can put even F here, say you give E node as 0.8 and F node as 0.2. So when it restarts, it will more likely to restart from node E. So this is a personalized PageRank, and then you can see if we draw it again, so the A is still, the most important ones, and the B becomes 0 importance because it's impossible to reach B from node E, right? So the B kind of gets almost, it basically just gets 0 importance because it's impossible to reach from E. Yeah. So this is some toy examples, and I hope you are also ready. If you click on it, it should be directly copied to your own Colab and run, right?
Hi, sorry, basic question about your Jupyter notebook here. I'm still new to this. I still have to go through it, but you can save data, code, everything. It's all here in this.
Yeah, it's
Jupyter
all
notebook?
here. All you need is just one notebook. You don't need any. You don't need any data.
Great, thank you.
Yeah, and then later on, since it's a personalized PageRank, and just use the most standard recommender dataset, the movie lens data. So, and again, I just directly download the data from this link and then unzip it and then reading the user item and user item interaction data. So in the end, you will get this, right? So this is a user ID, movie ID, and also the ratings that the user gives to this movie. In order to make it more interesting, because I think I want to see what exactly that movie is, so I just merge the movie back to this interaction. So you will see what exactly that movie is. So this is all the data that we're reading. And then we can create a graph from this, right? So you notice right now that it's not directional graph. So earlier I create a DI graph. So it's a DI graph, so it's a directional graph. So you will see this directional links. And over here, since I don't see there's any direction, so I just put a graph here. So it's an directional graph. And then we can directly add nodes from this. And also add weights, right? So add weighted edges from this user item, and also I put the ratings as a weight for the link. And then you can print the information of this graph. So it has this many nodes and this many edges. So you can again run the PageRank on this time with alpha 0.85. So this is kind of, I would say, the global ranking of movies just based on the pure links. So, and then return top movies. So this is the top 10 movies just based on the links. Star Wars comes off first, so no surprise, I would say. Someone may disagree, but yeah, so I think this is I think it's a pretty reasonable global ranking list to begin with just one, with just a small data and just the first one.
Yeah, a quick question.
Mm-hmm.
Before you mentioned about when you have the edge, you have income reference or outgoing reference. When you add this weight on the edge, it doesn't matter which direction?
Yeah, because so for the previous paper, you want to jump back and forth, right? So for this user, yeah, so you see this? Because for these two set of nodes, you want to jump back and forth. You want to first item will jump to a user, and then user jump back to an item. Right? So it's not directional at all. So it will be bidirectional in order to do this, in order to figure out the connections among the items.
Okay.
Yeah. So because you need to jump this way and also jump backward. So it's definitely bidirectional, then becomes unidirectional. And then, yeah, just something to try with, because to see what happens if we put weight here, because some users just likes the movies a lot, and some users or the same user dislike some movies, right? So for those with high ratings, you will become more likely to pick this link comparing to the link that the user dislike. So with the rating thing, so then in that random jump back forth, it will the server will more likely to pick the links with the high ratings. So I think that is to our expectation, because we want to give a ranking that the user likes.
Okay, thanks.
Yeah, and then we can do a personalized, and then we can specify the user node over here, and then we just return the top movies for this user based on this algorithm.
Could you explain how the rating works? Because the previous one for all the outcoming node, you divide as like 1 out of 3. So the rate moving rate here, it impact the weight for each node.
Yeah, I haven't exactly looked at this implementation, but I mean the source code of this PageRank implementation. But I believe that, yeah. So if it's more rating, so higher the weight, the higher the values in that entry, right? So if it's like say 4 and 1, and then one entry say get 0.8, the other get 0.2.
I see. Okay. Cool.
Yeah, I think
so
there's
that seem to be that weight seem to be able to use some model to assign that weight. I'm not sure whether that's the next webinar topic.
Yeah. Oh, yeah. Maybe
yeah, because in order to link, my previous question is here we have the user and item there, but we treat each connection, each link as the equal probability there. This example you gave, the rating treat the weight for each link differently, and that weight actually can be use some model to kind of really link the user and the moving features to decide the weight. Okay.
Yeah, but here is just based on ratings to see how strong that link is. Simple, straightforward model here.
Okay, cool.
One tricky thing is if a user has not rated a movie, does not mean that that weight is 0, right? That's pretty much the weight is 2.5 instead of scale 0, 5, right? That's different from the previous one that no connection means 0, right?
Yeah, but the purpose of it is to infer the missing, because for recommender is always to infer the missing, and of course the data is noisy and is incomplete, right? For any recommender, it has always just based on the links that already happened, right? And although the links are definitely incomplete and noisy, but that's the best we have for the model input.
So do we know how different is this from collaborative filtering? Similar or different? Is there an embedding calculation involved?
So I think I have seen a course called Advanced Recommender on Coursera, but maybe I can, whenever I find that link, I can put it in the comment. Because when I see that video, and they show actually the performance of say the matrix decomposition method, like collaborative filtering, right? And then this PageRank, and actually PageRank seems outperform a little bit in terms of the movie lens data. So I think that's a very interesting to see. I mean, the most straightforward method, right? So PageRank is also most straightforward, and then the collaborative filter, you just use the matrix factorization method, and then you compare the performance. Yeah, I have seen that, and actually it's also very surprising. And I see there are recent papers that are using PageRank, so recently published papers that are using PageRank to update their recommender system on the fly, because the PageRank is just so quick to compute, and they use PageRank to rank for the recommender system. And it seems still a popular branch in recommender system.
Thank you.